Hello, Luke. Welcome to Lesson 37. So today we will be talking about inequalities and then graphing inequalities. All right, so let's just go ahead and get started. Let's talk about comparing some numbers. So if I have the number 2 and the number 4, and I wanted to compare these two numbers, which is often what we're trying to do in mathematics, how could I compare them? And you might say, well, I could say potentially 2 is equal to 4. That's one option. It would be incorrect, but that's an option. Or I might say 2 is less or greater than 4. That's another option, also incorrect. Or I could say 2 is less than 4, right? There would be three ways that I could compare these two numbers. 2 is equal to 4, 2 is greater than 4, or 2 is less than 4. And in fact, those are the only three ways that I can compare these two numbers. Try to come up with another one, and you won't be able to. There's only three ways that we can compare them. 2 is either equal to 4, or it's greater than 4, or it's less than 4. There's no other option there. So those would be the three, and of those three, we've talked extensively already about this first scenario. 2 is equal to 4. Whenever we have this equal sign, remember we call it an equation. It's just an expression on either side of an equal sign. All right, and we've worked extensively with equations up to this point. So we have really covered this one fairly well, and you've gotten pretty proficient at this point in solving equations for unknowns. All right, these second two we haven't really talked much about, and that's what we're going to be talking about today. These are called inequalities, and it should make sense because an inequality is not equal. If you look at that word, inequality, you see the word equal in there. And then the in, which is Latin for not. Not. So we have not equal. All right. So this one is called an equation. These two are inequalities. All right. They are not equal. All right. And that's why we don't use the equal sign. We use these other symbols. All right. And hopefully these other symbols, you've learned them in the past, and hopefully they don't require much of a review. But remember, in a true inequality, this symbol is always going to be opened up towards the larger number. Okay? I don't know. In my first and second grade years, my teacher would tell me that think of him as Al the alligator, and he's got teeth, and he likes to eat big numbers. Okay, and he's always eating the bigger number. I know it's silly, but that has kind of in the back of my mind stuck there for many years. So that greater than symbol, it's always eating the bigger number. All right, so we would read this as 2 is greater because the greater part of this symbol is pointing towards the 2. 2 is greater than 4. All right, which obviously is not true. And then down here we have 2 is less than. We read that less than because the closed part of the symbol is facing the left. So we have 2 is less than 4. 2 is greater than 4. All right, and hopefully that's just a basic review from previous years. All right, so let's start talking about these two. And we're going to complicate things a little bit by throwing in some variables. So let's say instead of comparing two numbers, I'm comparing a variable with a number. So let's say I've got x is greater than 2. Okay, so I have a variable in this case, an unknown. All right, now these ones, it was straightforward and easy for us to say 2 is greater than 4. No, that's false. That's a false inequality. 2 is less than 4. That is a true inequality. Okay, over here, if I were to ask you, is this a true or a false inequality? You would say, I don't know, right? Because we don't know what x is. So this is, maybe I'll write this. This is called a conditional inequality. Conditional inequality. Okay? And what that means is it is true conditioning on the value that we put in for x. All right? So I could select a value for x that would make this inequality true. I could also select a value for x that would make this inequality false. All right, so it's conditioned on what we put in for x. It's dependent upon what we put in for x. All right, that's why we call it a conditional inequality. All right, so the question then becomes, well, what would be all of the solutions to this inequality? What would be all the numbers that I could place in there in place of x to make this inequality true? All right, it's very similar to what we asked when we looked at equations. If I have, 3x equals 12, I might ask you, what are all of the numbers that I could place in here for x such that this equation is true? All right, in this case, there's only one answer, and the answer is a 4. The x has to be a 4. All right. Over here, though, if I were to say, give me the solution to this, you might say, well, gosh, it's more than one solution. I mean, I can think of a couple of solutions off the top of my head. I mean, a 3 would work. 3 is greater than 2. A 4 would certainly work. A 4 is greater than 2. 2.1 would work. 2.1 is greater than 2. A million would work. I could go on forever finding numbers that are greater than 2. All right, so if you were to ask me for the solutions to this, I would be writing forever. Okay, so the first thing here to recognize is that when we have inequalities and we're told to find the solution to it, we need to remember that actually the solution is going to be a set of solutions. A set of solutions, which just means that there will be many solutions. It's a whole set of them. All right, so a set should imply, throwing in some braces here. That would be our set, and filling the set with a bunch of solutions. So we're going to have, a ton of solutions in here. It's a big bucket of solutions. It's a set of solutions. All right, so it won't be just a single one. It'll be many answers or solutions that will work for this x. Okay, so how can we write this set of solutions? Well, we're going to do it by drawing a picture because we can't do it by listing all of the possible solutions. We'd be writing forever, and I just don't want to do that. I don't want to put you through that. So instead, we're going to draw a picture. So let's draw a number line. Okay, so there's our number line, and on the number line, we'll just throw in a couple of our basic numbers here. Here will be 0. This will be 1. This will be 2. This will be 3 and 4 and so on. And then over here we have a -1, a -2, a -3 and so on. All right. So to give the solution, we are going to graph the set of solutions on this number line. Right? We're going to draw a picture of the solutions instead of actually writing all of them out. So to draw it, we need to say that x is greater than 2. So where does that put us? Well, here's our 2, right? This is the 2. And x is anything that is greater than 2. So x is going to be anything in this direction, right? But it's not going to include the 2. It wouldn't make sense to replace x with a 2 because this would not be a true inequality. 2 is not greater than 2. That's not true. So we can't include the 2, but we can include everything after the 2. And to show that with this picture, we're actually going to draw a little circle around the 2. Okay? And then on our number line, we will just, and maybe I can just try to draw a straight line here. We are going to draw a line with an arrow on the end of it in this direction. Okay? And that, I'll just erase this so it's a little bit cleaned up here. That would be our solution. We just drew a picture. And all we're saying here is that the answer is anything that's just greater than a 2. That's why we have this hollow circle here. We have this hollow circle to show that 2 is not a solution. But if you go just a teeny bit off of the 2, and you can go as teeny as you want off that 2, that would be a solution. So it's anything just past the 2 onwards for infinity to the right, because everything to the right would be greater than a 2. All right? That is how we would write our answer. That's it, right there. You can pick any spot on this arrow, pull that number off the number line, and that'll be a solution for this inequality. All right, over here, all of these numbers, if you were to pull a number off of the number line in this direction, none of them would be a solution to this inequality. All right, very good. So let's try another one here. What if we've got x is less than 2. Okay, x is less than 2. Well, here it's the same concept. Let's draw our number line. Okay, and then we'll maybe put our 0 maybe over here in this case, and we'll just draw a couple of positives here, 1, 2, and 3. And then over here to the negative, we have a -1. We have, whoa, that's a little bit spacey, -2, -3, -4, -5, and of course we don't have to go this far, but we're just going to fill out the line, -6, okay? And we're saying that x is less than 2. So first of all, it's important to recognize that x is not a 2. It can't be a 2, which is located over here. But it can be anything less than a 2. So once again, we're going to draw our little circle around the 2. Okay, we draw a little circle around the 2 to indicate that 2 is not going to be a solution. And then from there, we'll draw our arrow this way on the number line. And that would indicate our solution, right? So it's anything less than 2. It's smaller than 2. So it's all of these negative numbers going on for infinity in the negative direction. All right? Very good. Now, the next thing, though, is sometimes it is desirable to include the 2 as part of the solution. So maybe I want x to be not only less or greater than 2, but maybe it's possible that a 2 would also work. All right. And to do that, we're going to introduce just kind of a hybrid of these, of a couple of these symbols over here. So we might say, whoops, that in some expressions, we'll write this as x is greater than or equal to a 2. X is greater than or equal to a 2. So we're kind of combining two of these options to just expand our set of solutions just by a little bit to actually include this beginning number, this 2 in this case. So we're saying here that x is greater than 2, but it could also be equal to a 2. That would also work. It could be equal or greater than a 2. And you can see how we've used this symbol. We've just combined the equal sign with the greater than symbol and just, eliminated one of these equal bars and placed the other bar right underneath. So it's a combination of the greater than and the equal sign. So x is greater than or equal to 2 is how we would read that. All right. Now on a number line, how would this work out? Well, we have our number line once again. And if we draw in our numbers, we'll put 0 here, 1, 2, 3, and maybe I'll just go up to 4. And then we have a -1 and a -2. All right. Now here I'm saying x is greater than a 2, but it could also be equal to a 2. So what that means is we find our 2, and we're saying, okay, he could actually be equal to a 2. So instead of using a hollow circle, we're going to use a solid dot. Okay? Because that would indicate that 2 is also a part of the solution set. All right? 2 could also work. If I replace the x with a 2, x is greater than or equal to 2, this is a true inequality because 2 is equal to 2, and that is part of the comparison here. 2 is equal to 2, or 2 could be greater than 2. In this case, 2 is equal to 2. Okay, so that does work. So that's why we're going to fill this circle in to indicate that 2 is part of the solution. And then from there, it's going to be anything greater than 2. So we're going to go off into the sunset in this direction, right? Forever and ever into the positive direction. All right. If we had switched this around and maybe let's just do that. Instead of saying greater than or equal to 2, maybe it was less than or equal to a 2. In which case, the only difference then would be that we would be taking this guy here. Let's see if I can do this. And just reversing him. Whoop. Right? And going off for infinity in this direction. But we'd still include the 2. Right? Because that is also a possibility. X could be equal to a 2. Okay? And that's really as far as we need to go today. So when we're talking about inequalities with unknowns, otherwise, you could think of them as conditional inequalities where there are multiple answers or solutions for this x, then in order to show those, we need to draw this picture. So this picture, this graph, that is our answer. Okay? That is our answer. I mean, if I wanted to, I could even, box this, I guess. This is our answer, okay, to the problem. All right, so it's pretty straightforward. I think pretty easy. A little bit of drawing that's involved. Have fun with that. I'd say the biggest hang up here is just to remember when to use a hollow circle and when to use a solid circle. Okay? Very good. Well, we will stop there and we will continue on tomorrow.